Okay, hello everybody.
Hello, everyone.
So we are 1 week ahead on the schedule, and now we are talking about the development of brain circuits and morphogenes even more. We have few questions this week, 4 exactly. So it's going to be a short hangout, except if some new question pop up in the hangout with the chat. So
please do not hesitate,
yeah.
Of course.
Exactly. So 4 questions. One was about proneural factors and an apparent contradiction with the notch signaling pathway. So basically the question was there is like cells who express proneural factors that becomes neurons, and those proneural factors activate the notch signal, which tends to inhibit neurogenesis. And so the person was like, this is contradictory. So it's not really a contradiction, as it could appear. This is classical in biology, that some processes tends to inhibit the cause of themselves, which is what's called a negative feedback loop. So you have a process that tends to create something, and the something that is created tends to inhibit the process itself. And that's the basis of homeostasis, which is like how to stabilize a dynamical system. And so in the case of this phenomenon of proneural factors that create neurogenesis and then the notch signaling inhibiting it, we have a stabilization of the neurogenesis through this negative feedback loop. There are other type of feedback loops. Yeah, there is also a positive feedback loop, which tends to be at the opposite, increasing even more a process that is fed into this feedback loop. But in biology, you need ultimately negative feedback loop, because if you have only positive feedback loop, then it explodes and you cannot have a stabilization.
So in other words, Guillaume, what is the qualification of life?
To me, it's like to be stable.
Exactly, be stable.
So to be stable in a dynamical environment.
Exactly. So life is a cycle, and so you should not be really be surprised by the fact that some factors can have a positive effect, and just by changing concentration, the targets might have a positive effect.
Mm-hmm.
All right, so let's go to the second question related to the link between expression of odorant receptors and their brain targets, the so-called glomeruli. The relationship is very simple. Once given stem cells decided that it's a kind of serendipity, one receptors will be chosen after 1,000 receptors. These receptors will be used as a guiding cues for the axons in order to penetrate the brain and find the glomerula, in which already thousands of axons are converging to these points and expressing the same receptors. So in other words, those odorant receptors are made to be expressed in the nose to recognize chemicals surrounding us. But before that, they are also used as guiding cues to make these wiring lines very, very stable. This is a very precise case of what is called exaptation that was defined by Stefan Jay Gould, when you derive one function that is determined by nature and use it for something else. You know, like my hands, for instance, can be used to write, but if I fall in the water, I would use them also to swim. So this is what exactly these receptors are doing. Do you have in mind another case of exaptation?
In my case, I've studied a lot imitation, and most of the people tend to see imitation as learning purpose. And in fact, for children, imitation is a social mean of communicating with the
and learning.
with the parents. And so you have like learning and social communication at the same time for the same function. So it's another very interesting example because across the development of the child, the ratio of use for learning and for social communication tends to change on top of this.
Exactly. So then the third questions relate to how the environment impact on the production of newborn neurons. So we have said learning, intellectual learning, as well as physical exercise promote the production of newborn neurons, and in more general sense promote neuronal plasticity. And the question concern the biomarkers that relate these actions, and it is proposed dopamine, of course, as all of you know. Dopamine is linked with the reward system and its pleasure. So when our actions go into the direction of what motivation push us to promote an action, then dopamine is released as a kind of reward system, encouraging us to do it again. And dopamine indeed have been shown to be positively linked with production of newborn neurons. So more dopamine and more newborn neurons in the brain. Regarding the other factors, oxytocin, we know indirectly that social interaction promote the brain plasticity. Whether oxytocin is directly linked to stem cells, these have not been shown. So if you have time, maybe you can do these experiments. What do you think here?
Yes, so on the oxytocin, it's also hard to disentangle social interaction effects on oxytocin and on dopamine, because now we have also more and more study on real social interaction in neuroimaging, for instance. We see that there is a strong implication of the reward system during spontaneous interaction. So that's intrinsically interacting with others is rewarding. And there is also a lot of study about how actually being isolated from others and not having social interaction as the opposite, and how it can have deleterious effect on the brain and, for instance, neurodegenerescence. So yeah, the role of oxytocin is also kind of debated those days, because it's clear that oxytocin has a big role in maternal attachment, for instance, or in social interaction, but recent studies also show that the oxytocin is not the love hormone as it has expressed initially, because it can cause the opposite regarding the outgroup, so the others that are not part of the pack of the family or the tribe. So it's an ambivalent hormone, because it can create maybe more love within, but more hate from the others' sides. So
exactly. And so the final questions concern the status of adult neurogenesis, and the questions concern whether there is a default states in which then experiments of the subject could enhance or inhibit. And indeed it is the case. As we already mentioned, there are positive or negative regulators that will promote or inhibit the production of newborn neurons in the adult brain. But there is also another factors that is aging, and more precisely, not really time in the brain, but more the accumulation of neuronal inflammation markers. And so there is now this idea that even time can be reversed. You can take a whole brain and remove all inflammatory markers and reverse and increase again this default state neurogenesis. So this is a really great hope for people like me, actually.
For everybody, for everybody, we are all concerned. But so yeah, it's kind of linked with the first question, actually. So that there's not a contradiction between having a natural state of neurogenesis and a decline with age, basically the feedback loops that we were talking about in the first question can be modulated by aging, for instance. So if the feedback loop is strengthened through aging, then you will have a more crystallized system, which like too much stability is not good because you cannot adapt anymore to the environment. So that's also to keep in mind with this kind of phenomenon, that it's not only a process, but its relation to other processes that then feedback and modulate the process to take into account in your way of seeing the phenomenon in the brain.
Yeah, this is coming in my mind, a French researcher in 19th century, Bichat, said life is death and death is life. And I think this is really what we are mentioning now with this idea of, feedback regulations.
Yes. So for instance, like apoptosis is needed to have your hands and with fingers and not palm like ducks. So you need death at some point to create life. Okay, well, for these philosophical notes, we start this new week. We hope you're still really enjoying the course, and do not hesitate to ask more questions, and see you next week then.
Yeah, a great pleasure to talk with you and Guillaume, and stay tuned. See you. Bye-bye.
Bye.